Hello everyone, welcome to today's class. Today we are going to look at approximation as a topic. So before starting significant figure, there are things that we need to understand. And what is that thing? Rounding up or rounding down a number. Okay, you can be asked to round off. So when you're asked to round off, that means we expect you to round it up or round it down, depending on what you have. Okay, when the last digit is between 0 to 4, okay, between 0 to 4, we round down to 0 and add to the higher place value. And when the number is between 5 to 9, we round it up to 1 and add to the higher place value. Okay, so this is what we are actually going to be doing a lot of time in different kind of approximation, because when the number is between 0 to 4, you are going to round it down to 0. Okay, now yes, when you add 0 to any number, you get back your number, so there will not be any form of change, okay, when you do that. But when the number is between 5 to 9 and you are rounding it up to 1 to add to the higher place value, the higher place value is going to change, is going to increase by 1. Okay, so this is basically what we normally do. Please, I will need you to understand this, because we are going to do it a lot of times on this particular topic. So let's start with significant figure. In significant figure, uh, we will be asked to approximate or estimate a particular value in a particular number of significant figure. So what are the things that we need to understand about significant figure? So when dealing with significant figure, these are the two things that we need to have in mind, okay? Apart from the rounding up and rounding down, these are the two major things that we need to have in mind while approximating a number in a certain significant figure. Now, the first thing we need to remember is that significant figure starts with the first non-zero digit. Okay, so if I have a number like this, where will I start counting my significant figure? I'm going to start with what? 3, because this is my first non-zero digit, first digit that is not 0. Then when I have a number like this, okay, I can start here to count my XL. Okay, I can only start from here to count with my from my what? SL. I can only start from here. Why? Because 3 is the first non-zero digit we have in this number. Okay, so but in this case, 3 here is the first, so we start here, 1 2 3 4. Here we also start from here, okay, to count. Okay, so you need to have that in mind. That's what we mean by that significant figure starts with the first non-zero digit in a number. Then the second one is that when 0 ends a decimal number, of course you can see your decimal number. Okay, when 0 ends a decimal number, it is not significant. What does that mean? If I have 0.10 and 0.1, they are the same. Okay, because this 0 here, I do hear a lot of time students calling this number here 0.10. 0.10 is a wrong way of calling that number, because it's a decimal number and the 0 there is not significant, and you don't call after the decimal place, you don't call the rest of the numbers or the rest of the digits in numbers, you call them in digits. So if you have a number like this, you call it 0.10. Okay, which of course the 0 there is not significant. So if I have 0.003210, So you don't go ahead and call this 0.003,002. No, 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 no. That's very wrong. Okay. So how do we call this number? This number is the same thing with 0.00321. So after the decimal point, the rest of the numbers, you call them in digits. Okay. So you can see that the two zeros here, they are not significant because they are the same. Okay. It's not like when you add three zeros, make this one bigger than this. No, of course, that's another place that students make mistake a lot when they are dealing with decimal numbers. You have a number like this. Okay, let me write this 0.10 and okay, let's say 102 and 0.7. And you see a student telling you that this one is bigger than this. No, because this one, in as much as it looks as if it is 102, no, that's 102 and this one is 0.7. Of course, the first digit here is 1, the first digit here is 7, making this one to be greater than this. Most of the time in checkpoint and the Cambridge IGCSE Cambridge exam, you are likely to see a question like this. Sometimes they will ask you to put uh, a sign for greater than or less than between a number like this. So if you are not careful, you notice that you make a mistake if you are looking at the numbers after the decimal place as a number, something like this, as 0 point, as 102 instead of just 102. Okay, so let's move away from that and now go and approximate some examples in a particular significant figure. So let us look at the following examples. So it's going to be a very quick topic. So we'll just solve two questions. We'll move to the next one. Okay, so that can be very quick. Now, we are asked to approximate the following to 1 and 2 xf. Okay, so the first number, we're going to approximate it to 1 sf, and they also approximate it to 2 sf. Okay, let me put and here 1 and 2 xf. Okay, so our first number is 4575. So A, we are going to approximate this number to 1 xf. How can we approximate this number to 1 xf? It's very simple. Remember, the first thing to remember is that the significant figure starts with the first non-zero digit. Okay, so in this number, the first non-zero digit we have is 4. So this is my first significant figure. This is my second. This is my third. This is my what? Fourth. Okay, so what do we do? I normally use a method where I put a little or a dotted line, a kind of separating what I need and what I don't need. And what I don't need does not mean that I'm going to remove this number entirely. No, I'm going to round them down to 0, remember. So it's going to, everything there is going to turn to 0. So we now ask ourselves the next digit. Please don't make mistake of starting from here to this one is up to 5, you bring it here, this one is up to 5. No, the next digit, just start with the next digit. Okay, the next digit, is it up to 5? Yes, it's up to 5. And what do we do when the number is up to 5? From 5 to 9, you round it up to 1 and add it to the higher place value. So this one is up to 5. I'm going to add 1 to this, so that will give me 5. Everything here is going to return to what? 0. So 5000. This is one significant figure. Okay, that's one significant figure. So if I take the second for the second 2 SF, so that will give me 4575 equal to, we'll do the same thing, count 1 2. So put our invisible line. I like calling it invisible line because is not meant to be seen. Okay, so the next digit there, is it up to 5? Yes, it's up to 5. What do? We add 1 to this. When you add 1, what do you have? 4 6. Then these 2 will give you 0 0. So that will give you our 2xf. Okay, so that's how we have solved that particular question in number 1. So let us look at number 2. Then we move to decimal places. So in the second question, we have 03451. Remember, the significant figure starts from the first non-zero digit. And in this number, the first non-zero digit we have is 3. So that's where we put our invisible line. So we ask ourselves, the next number or the next digit, is it up to 5? If it's not up to 5, what do? We add 0 to the higher place value and make every other thing there to be 0. So that will give us, when you add 0 here, you're still going to have your 0.3, then everything turns towards 0. Okay, so this is what you should have. But you and I know that from the second point under square figure, all these zeros here are not what? Significant. So we have it as 0.3 in 1xf. Okay, so let's do the second one. The second one will give us 0.3451. So when you do something like this again, okay, oh, we are supposed to do that here. Let's do it here. When you do that here, you have 5 as a digit next, okay, and 5, of course, is a number between 5 and 9. So that will make you to add 1 here. When you add 1, you are going to have 0.35. Every other thing turns towards 0. But remember, zeros after the decimal point for a decimal number will not be what? Significant. So that will give us 0.35 n 2xf. Okay, so that's how to solve problem on significant figure. So you can go back to your textbook, pick up some examples and try your hands on them. If there's any challenge, make sure that you reach us in our in the comment section. Of course, I'll be willing to answer your questions. So let us look at the next thing, which is decimal place. So we all know what we mean by decimal point. Okay, so any number that contains a decimal point means that that number is uh, uh, has a particular decimal places. Okay, and decimal place, or how do we start counting decimal place? So for decimal place, we see that the number of decimal place or places starts immediately after the decimal point. So that's where you start counting your decimal place. For example, if I have 1.2, this is in one decimal place. Okay, DP, yes, that's what we use for decimal place. If I have 3.781, this is in 3 decimal places. That's because I have 3 digits after decimal point. Okay, so that's just all we need to know on decimal place. So let's solve example. Of course, when you're asked to approximate, you count after the decimal point the number of decimal places you want. You take your approximation, okay, or you take your round up or round down, whichever one that you're going to have, then you get your answer. So let's see a couple of examples and see how it will look like, okay, to approximate in particular decimal place. So this is our example. We say approximate the following to 1 and 2 decimal place. So each of these questions, we're going to approximate it to 1 decimal place and 2 decimal places. Sorry. Then this one also, we're going to do the same. Approximate to 1 decimal places or 2 decimal places. Okay. So starting from the first one, we are going to first of all approximate it to 1 decimal place. Okay. So you count after the decimal point. You don't count this one included. After the decimal point, you count. So this is my 1 for 1 decimal place. I'll put my invisible line. I'll ask myself, the next digit there, is it up to 5? Of course, yes. So what do? I add 1 to this. That will give us 2.8. All this one will turn towards 0. Okay. But remember, 0, and when 0 ends a decimal number, those zeros are not significant. So what do? We cancel it out. So what is our answer? 2.8. This is in 1 dp. Now for the second one, the same number, 2792. So we count 2 decimal places. So we count 2 numbers after the decimal point, 7 and 9. Okay, we'll put our, so is 2 up to 5? No. So we are going to add 0. Okay, so that will give us 2.79 into dp. Now, a question is that what of if 2 is up to 5? What is going to happen? What is going to happen? You add your 1, what we have been doing. Unfortunately, 1 plus 9 will give us 10. So we can't write 10. So we write 0 and take the next one to this place, which will still give us the same thing with what? 2.8. So the only thing we can do now to signify that, yes, we actually did what you are asking us to do is to write it like this, which we know that the zero there is not significant. So it's almost the same with this. Okay. So that's why most times they will hardly give you a such complicating questions, because what is the need? Giving me 2.7 79, let's say 6, and ask me to approximate it in 1 dp and 2 dp when both of them will give me the same value. I mean exactly the same value. Okay, so that's how to do your decimal places. Now let's move to place value. Okay, place value, we need to understand a couple of things. Okay, so in place value, it's important that you understand the place value of every digit in a particular number given to you. Okay, most time, okay, I will not point out all the place value of all the number. Of course, we have infinite number of digits. Okay, that's the same way we have infinite number of place values. Okay, so I'm going to just give the ones that are very common. For example, if I have 1, 2, 3, 4 points. Okay, let me have 5.678. Okay, okay. Let's just have a number like this. Okay. Now we need to understand the place value of each digit. So this one, the place value of this is in units or whole, and this one is our tenth, and this one is our hundredth, and this one is our thousandth. Okay, now this tenth can also be 0.1. That's the same thing. You can be asked to approximate to the nearest 0.1. Okay, and this one here is 0.01. Okay, and this one here is 0.001. So you need to understand what these things mean. Okay, because sometimes they will not tell you to approximate to the nearest tenth. They will ask you to leave your answer in the nearest 0.1. That's tenth. 0.01, that's 100. 0.001, that's what? Thousand. Okay. Now coming to the other ones, the integers now. So this one here is tenths. This one here is 100. This one here is 1,000. Of course, tens of thousands. Most times they will not get up to that. Now, if they don't want if they don't want to ask you in the nearest tens, they will tell you in the nearest 10. If they don't want to ask you in the nearest 100, they will tell you in the nearest 100. If they don't want to ask you in the nearest 1,000, they will tell you in the nearest 1,000. Okay, so these are the things that you need to understand while making any form of approximation on place value. Okay, they can ask you, instead of telling you approximate to the nearest 1,000, they will tell you approximate or leave your answer in the nearest 1,000. Okay, leave your answer in the nearest 100. Leave your answer in the nearest 10. Okay, that's the same thing with tens. So when you identify the place value that you are asked to approximate, all you need to do is, after that particular digit that represents that particular place value, you put your invisible line and do what we have been doing. Okay, so I'm going to, of course, this one, there are a lot of, we can't exhaust all kind of questions that can be asked here, because they can ask you nearest thousand, nearest tens, nearest whole, nearest tenths, So we can just solve a couple of them, maybe two questions or three. Okay, then we now move to boundaries. Okay, when they give you a particular boundary, lower boundary limit and upper boundary limit. So let's look at some few examples on place value. So we are asked to do this number of questions. Okay, so the first one we have is 34571 to the nearest 100. Like I said, this is the same thing with just saying nearest 100. In as much as we are saying 100, it means that you should approximate it to the nearest 100. So I need to identify the digit that is the 100 in that bears the 100 or the place value of 100 in that particular number. So if you come here, if you look at this number, these are our units, these are our tens, and these are our digits. So where are we going to put our line after our uh, after 5? Okay, so that's where I'm going to put my line. So let's do that here quickly. 3, 4, 5, 7, 1. So this unit, tens, 100. So that's where I'm going to put my number, my invisible line. So that will give us, this one is up to 5. Okay, so you add 1, you have 3, 4, 6, 0, 0. Remember, the zeros are not the ending of a decimal number, so you cannot clean it because it's very, very significant. If you clean it, you are going to have 346, which is not approximate value for this. Okay, so you don't clean the zeros because it's not a decimal number, or because it's not ending the decimal number. Where we clean it is when it ends a decimal number. Okay, so this is answer for number 1. So let's first look at the second one. The second one is nearest tenth. Okay, so we need to identify the tenth there. So number 2, sorry, 107.51. So the digit that represents tenth in that number is 5. So we'll put our invisible line there. So this will give us 0 because it's not up to 5. So that will give us 107.50. So because this is a decimal number, that's the difference between these two. This is a decimal number. So since it's a decimal number and 0 is ending it, we can wipe it off. Okay, remember, you don't wipe off this one. You can wipe off this one because this is a decimal number and 0 ends it. You can remove it. This is not a decimal number, 0 ends it. You cannot remove it. So number 3, we have 0.921 to the nearest whole. Yes, I like this question. To the nearest whole, you can see here we don't have, or we do, but the number that represents the nearest whole is 0. So does that stop anything? No, it does not. So we come and put our invisible line here. So that will give us, is it up to 5? Yes. So we'll add 1 to this. We have 1.000. Remember, zeros ending decimal points. So you can actually do what? Wipe it off. So that will just give you 1. So the last one is 721.45. Okay. Now, you can see a similarity between this one and this one. Okay, well, this one is even better than this. At least we are seeing 0, which represent the whole, okay, or the place value of unit. But in this case, we don't even have any form of representative of 1,000 because the first digit we have represent 100. So what are we going to do? Add your 0. Use your 0 to complete whatever you need. Okay, because 0.01 and 1, they are the same. Okay, they are the same. So what we do, we put something like this. What would that give us? That will give us, this is up to 5, so add 1 here. So 1,000.00. Okay, so this is what we have. Now, how are we going to leave our answer? Of course, these decimal points, these zeros, we wipe it off. So we have our answer as 1,000. Okay, so these are how to approximate in place value. Now let us look at when you have done an approximation, whether in place value, whether in decimal places or significant figure, and you are not asked what is the boundary or the boundary of that particular number. How do we do that? Okay, so I'm going to show you a couple of examples so that you can use that to learn how to create the boundary or find the boundary of the number that's approximated to a certain value. So let us create a scenario. Okay, if we have approximated a certain number in the nearest tens and the result gives us 170, nearest tens, remember that. What are the numbers that we have approximated to get this result? That's what we mean by boundary. Now we have the upper boundary and we have the lower boundary. So sometimes when they ask this question, they expect you to find the upper boundary or upper boundary limit and the lower boundary limit. Okay. Now, let me show you examples. If we have 170 to the nearest tens, it will give us this. If we have 171 to the nearest tens, it will give us this. If we have 172 to the nearest tens, it will give us this. If we have 173 to the nearest tens, it will give us this. If we have 174 to the nearest tens, it will give us this. And if we have 175, it will not give us this to the nearest tens. So this is the limit. This is the highest we can get to, but this is the limit. Now let us come to the other side of it. If I have 169, I'm going to still have this. If I have 168, I'm going to have this when I approximate to nearest tens. If I have 167, I'm going to have this. If I have 165, I'm going to have this. But if I have 164, nearest tens, I will no longer have this. So this is the boundary again. Of course, we cannot get to this, we cannot get to this. Now, how do we create this boundary? It depends on the inequality that you want to use or inequality that have been used for you, because most times, especially in checkpoint and the IGCSE exam, they will put uh, 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 an inequality for you and ask you to find a value. Now let us create different inequalities for this. If I have a number less than equals to 170 less than equals to a number, okay, and I have a number less than equals to 170 less than a number, and I have a number less than 170 less than equals to a number, and I have a number less than 170 less than a number. Different inequality determines what I will write. Whether I'm going to write this or I'm going to write this. Whether I'm going to write this or I'm going to write this. Okay? Now look at this. They say that less than equal to. Less than equal to. Okay? So which number can we put here if I have less than equal to? In this case, I cannot put 164 because 164 cannot be the number. Okay? Because if you say less than equal to, it simply means that yes, this number is actually, we can start from this number and we can start from this. Okay, so in this case, a number that is less than 170, but when you approximate it, it can give you 170. So in this case, what we can write here is 165. Okay, now coming to this place, I can write this. If I write this, that number have to be almost equal to or can also be equal to 175. And if the number is 175, when I approximate it to nearest tens, I won't get this. Okay, so in this case, what I'm going to write is what? 174. Okay, now coming to this one, a number that is less than or equals to 170, okay, from the lower boundary is less. Okay, so we can have it as 165. Then for this is less than Strictly less than. That number have to be less than the actual number I can approximate. Okay. Which number can be less than? It have to be less than this. 175. Because any number that is less than 175 can be approximated to nearest tens to give you 170. Any number at all. So long as it's less than 175, if I approximate it, it's going to give me, it to the nearest tens, is going to give me 170. Now, coming to this one, a number that is less than 170, a number that is less. So that number is going to give me 164. Remember, we are dealing with integers now. We cannot get a number that is decimal points. So let's deal with the integers, because after this number, the next number I'm going to have is this, in the set of an integer. Okay, so coming down here, of course, we have to have what? 174. Then this one will give us 164, and this one will give us 175. Okay, so I hope you understand this limit. So I'm going to do another example so that you can get this well. Okay, all right, so let's take this one as example one. Okay, now let's move to another example. So in this question, they ask us to write out the missing number in the approximation of a number to the nearest 100. So when they approximate a number which we don't know to the nearest 100, this is what we have as our value. So they're not asking us to find the limit. Okay, find the limit. This is the lower. We need to find the upper. Okay, now this number is less than or equals to this. Of course, it's less than or equals to, it's less than that. So when you approximate this number, you are going to get this. Then what number will be here? Okay, remember, there is a strict what? Inequality here. Okay, it's not like there's less than or equal to. Like in the previous example, okay, we show when we have less than or equals to what normally happen. Okay, so here, what are the numbers? Let's look at 17 or 7500. Okay, 50. And let us also look at 177 40. Now, if you use this one, or if which one of these two that is going to perfectly fit in here, because it has to be one of these two. Okay, it has to be one of these two. But if you look at this one here, if I approximate this number to the nearest 100, I'm not going to get this. If I approximate this one to the nearest 100, I'm going to get this. But remember, they put less than, strictly less than. So that number have to be less than. So which number, if I put, is it this one? Is it the limit or this one? Okay, so the right one to put there is 17750. Why? Because we are looking for a number that is less than this, and the next number that is less than this is this one. Okay, so less than this that can be approximated to give you this. Okay, so this is where we are going to end this topic on approximation, and do well to check back for interesting topics in mathematics, and please share our videos and subscribe to our channel and give us a thumbs up. See you in the next class. Thank you.